Hey, welcome back, guys, to my channel, and we're gonna continue this series. Top 150 interview questions that you must know to pass the interviews. And to be honest, most of these things you should be familiar with them. For example, I haven't really tried this one, majority element, but if you've worked with arrays or strings and data structures and things like that, then you should be comfortable solving some of these. For example, I haven't tried this one. Let me go back. Okay. So I was gonna try this one, but let's try the other one, because this one is a little too easy. It's just saying that the majority element is the element that appears more than n divided by 2 times. That's what it's saying. So yeah, so it's the element that appears more than half of the array's length. Okay, okay. Yeah, so I think I have an idea here. So let's just say this is the number that we're looking for. So right now we're just gonna set it to none. Yeah, I've been coding in JavaScript, that's why I put that there. So we just want to iterate in there. We wanna iterate in there. And I believe it is not sorted. So I think you may have to do like an nested for loop, for example, for I in nums, and also for j in nums. I was gonna do I, but it's gonna be a little bit confusing. So we just want to do if I. So you actually wanna set this one equal to that. Actually, no, let's just set it equal to none. And let's just set this one equal to that. This one will keep track of how many times a number appears. So if I was j, I believe we can just run this just one time. Like we go through the array one time. But then again, yeah. So I was thinking maybe we can just run it through it like one time and then break the for loop and then just return. But I believe this is only gonna be comparing the first number. So we may have to run it a couple of times. So yeah, we may have to just do um, n squared. That's gonna be the big annotation of n squared, time complexity, if I should say. So we just wanna see if that's the case. Then just wanna increment it. So I actually wanna check the index. Let's just do that. We just wanna check the index. Just give me one moment while I try to see how that's gonna work. Yeah, I just wanna see the logic here. And then else we just want to, so if that's not the case, then we just want to continue. We don't want to do anything. And we actually want to check if we get to the okay, if that's the case. So we actually want to reset this. We just want to reset that. Hmm. Now we wanna see if car is bigger than this logic right here. It needs to be the majority element is the element that appears more than that. So I assume that you may assume that the majority element always exists. So we assume that it always exists. Okay, that's fine. So it appears more than that. Yeah. 1.5. So I assume they're not gonna be more than, so we're just assuming that there is, I assume that there is no gonna be any elements that, yeah, I assume there's only one element, so we don't need that much logic if we assume that there's only one element that appears at that one time, like that many times, you know. Yeah, so in keeping with that, so we don't need that. We do not need that. Because I thought maybe we're gonna have to be a little bit fancy, but we are not gonna need to do that. Yeah, we're not gonna do that. Hmm. Try to see how we gonna do that. Uh, mm, 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 mm. Yeah, just set that equal to check. And if k is equal to bigger to linear norms, divide 2. So I believe that's pretty much it. That's pretty much it. If not, we go on to the next one. We check the next number if that is not the case. Guys, we're gonna go ahead and submit this. I haven't tried it, so if I tried it, saying non-type. Okay, so yeah, I just put them to 0. Put them to 0. Python is beginning to be a little like C and C++, but that's on me. That was on me. That was on me. Is it taking a little longer than usual? Maybe. We'll see. Yeah, the time may got exceeded. I think there should be a better solution here somewhere. There should be a better solution somewhere. So it does work. It does work. The only problem is that it's taking like a crazy long time. So I wonder if we can break it upon the first time. So let's say this is the, and we're checking that. It's gonna check that against all the numbers. Yeah. Yes, so is this actually gonna work if I break it? I don't think it's gonna work because if you are like comparing this and then the other loop is gonna go to there, it might turn out to be that this one might be 1, and 1 is less than how many times 2 appears. So I believe it's not gonna work. So this does work, except this is not the most optimal solution, but it does work. Yeah. Okay, so I'm just gonna try to see if I can find. I'm gonna pause this. Pause it a little bit. So I tried running this method in Python that counts how many times an element appears, and it turns out that this little line of code is pretty much, even though it is a method, so this is like, it's gonna go through the list once, but then this has another for loop inside of it. So it's pretty much the same thing that I was doing, kind of the same thing. So it's still taking a little too long. So I'm gonna try to find a faster way. Yeah, so apparently this is the optimal solution right here. I tried solving it, tried to implement an optimal solution. Unfortunately, I wasn't able to do it. Unfortunately. So I had the help of ChatGPT right there, and apparently there's a guy called Boyer's voting algorithm, and this is called right here. It's, I guess, is the one that made the algorithm in the first place. So this is the optimal solution. So whenever you're going through all the numbers in the list, and initially you just wanna set the number that's gonna be the majority element, you're gonna set it equal to the current index, and this is where this stuff happens. You just wanna check if the current index is equal to the number, and if that's the case, you pretty much increment how you just want to increment by one, and if not, you just want to decrease it by one. And that's pretty much it. I don't fully understand how. I can kind of see the logic, but I just don't fully understand this part right here, because it's saying that if the current index is equal to number, I believe that's what it's saying. I believe that's not what he said. Let me see here. Yeah, so if the current index, yes. Which on the first time we literally set it equal to none. If that's the case, then we just want to increment this by one, and if not, we just want to decrease it by one. That's the same logic, except I think that's I forgot what it's called, that one line if statement or else. I forgot what it's called, but I think it's gonna have the same effect. It's gonna have the same effect. Yeah, yeah. This is the optimal solution. That's the optimal solution. Yeah, who knew? But so this is so I was able to solve it, but not in the best possible way. But this is like a good way to solve it. Okay, we'll stop here for now.